Right, we have the integral of x sine 5x sine 3x dx. So let's go ahead and solve this integral. Now before we begin, I want to beg that please subscribe to the channel below if you have not subscribed yet. I produce content almost every 2 days about interesting problems in math and physics. So let's go ahead and solve this problem. Now if you look at this problem, we have a product of two trigonometric functions. For such problems, we usually take two methods. The first method is recognizing a function and its derivative. Now, of course, in this case, we have sine 5x, sine 3x. All of them are sines, so there is no function and derivative case. So the second thing that we usually want to look out if we have a product of two trig functions is to actually separate them, because this is a product and it's difficult to deal with, but using the factor formula we can split this up. So let's go ahead and do that. I'm going to begin with something that you probably know of in trigonometry called the factor formula. If I have cosine of p, right, minus cosine of q, how does this expand? This becomes negative 2 sine of p plus q divided by 2 sine of p minus q divided by 2. Alright, now why did I choose this? Well, because it contains sine and a sine, and here I have sine and sine. So I want to get a way of converting the sine into a difference of cosines, which I can easily integrate. Alright, so let's try to make a relationship here. I'm going to get this and try to make it equivalent to this. So just get this negative 2 sine of p plus q divided by 2 cos of p minus q divided by 2. I'm going to make this equivalent, not equal, but equivalent to sine 5x, right, sine 5x, sine 3x, right? And by direct relationship, I can deduce that p plus q, well, I should say divide by 2, this is going to be equal to 5x. Also, I can deduce that p minus q, right, p minus q divided by 2 is going to be equal to 3x. Now, of course, in this case, this means that p plus q equals 10x, and in this case, I mean that p minus q equals, what's that? 6x. I'm just multiplying 2 on both sides, and if I solve these equations, let's see what answers we get. If I just, add the two equations, I'll have 2p. If I add this plus this, this plus this, that's a 0. 10 plus 6, that's a 16x. So I'll have p as 8x, and then I'll have q as, if I substitute 8x anywhere here, let's say if I substitute this p as 8x here, this is going to be 2x. Alright, so there we go, we have the values of p and q. Now I'm going to come back and try to rewrite this in a better way. So that's going to be, just a moment, I draw this line here to separate my work. Okay, alright, nice. So the whole of this, I should now say that sine 5x, oops, didn't get a pen, okay, here. So sine 5x, sine 3x is equivalent or equal to, in this case, negative 1/2. Why negative 1/2? Well, because there is a negative 2 here, so this is negative 1/2. Should open brackets here of, what's that going to be? Okay, cos p, that's cos 8x, minus the next, that's, what's that? That's cos q. Okay, that's cos 2x. Alright, so that's our new sine 5x, sine 3x, and we are going to substitute that here. So let me go ahead and do the substitution now. So we have this, just to write it now, it's the integral of x times -1/2 of cos 8x minus cos 2x, right, dx. So the -1/2 is really a constant. I can write that outside. So I have -1/2 the integral of x cos cos 8x minus x cos 2x dx. Alright, now I have two separate terms in the integral, and I can integrate each of them independently. And when you look at these, they are a little bit simpler to integrate because it's a product of a polynomial and a trigonometric function, so I can use the technique of integration by parts. So I'm going to use a very simplified way of integration by parts to do this. Let me just go to a new page and try to work on this. So the first one is x cos 8x. Let's see what this integral is. I'm really not going to go the first principles method. I'm going to use simpler table method here. So I'm going to write the function that is easy to differentiate, and that's dx, the x, and then the one that is easier to integrate, that's the cos 8x, right? So I'm going to assign the signs here, positive, negative, positive, and so on. I'm going to differentiate this. I'm going to integrate this. So if I differentiate x, I get a 1. That's the first derivative. If I differentiate the second time, I get a 0. Okay, that's nice because that shows us that we'll stop there. Then if I integrate cos 8x, that's going to be 1/8 sine 8x, right? Okay, if I integrate that again, okay, that's -1/64 sine, cos 8x, right? That's nice. So the integral here is actually, so let's say x times 1/8x, then minus this. So that's going to be x/8 times sine 8x. Okay, this minus and this minus, so we've got a plus there. 1/64 cos 8x. So I'm going to write this. Okay, of course there's a constant here, but I'm just trying to simplify this. So I'm going to write that for all this, the cos 8x. So I have my final answer as -1/2 of, okay, what answer did we get here? Just go to the next page and see. That's x/8 sine 8x, x/8 sine of 8x, that was plus 1/64 cos of 8x minus, okay, let's also work on this integral, the integral of x cos 2x. So let's just do that, the integral of x cos 2x dx. I'm going to use a similar technique here. So I have x here, then I have cos 2x plus minus plus, the derivative of x is 1, then 0, the integral of cos 2x, so I'm differentiating this, then I'm integrating this, right? So the integral of cos 2x, that's 1/2 sine 2x, that's the integral of this is -1/4 cos, right, cos 2x. So let's write the final answer here. This times this and this times this. So this integral is x/2 sine 2x plus, okay, plus 1/4 cos 2x. Alright, so let's get this also and take it behind in our answer. X over 2 sine 2x. So remember, this is a minus, so x over 2 sine 2x. Okay, the next term is also having a plus, so this minus here will make it a minus 1 over 4 cos 2x, and all this plus a constant of integration. Alright, I don't think there are some terms that are simplifying here, so I can just stop at this as my final solution. So thanks for watching this video. Please, again, I request that you please subscribe to the channel. I upload interesting problems. Also comment below to tell me what you think. If you have an interesting problem, you can send it to me by email or just leave it in the comment, and I'll consider it for one of my next videos. Thanks for watching. See you in the next video.